Saverio Venrelli, working for Siemens Energy. I'm the global responsible for the batteries, so sales of batteries for marine and offshore globally. With marine and offshore, I do not mean only vessels or ferries. We mean also offshore drilling, and we mean also offshore wind, and especially the upcoming floating wind, both in off-grid mode, but also in grid connection mode. Yes, I will talk about lessons learned with batteries and vessels especially. Before we start, I will talk about what is pioneering. A pioneer is someone that doesn't follow the rules or the given pathway. A pioneer is someone that makes solutions where there are no rules. Then you pave the way for creating then rules. This is something that we have been always doing. Personally, I'm allergic to follow. I'm a very bad follower. So fits very well, with what Siemens Energy does. Our journey. We started with batteries already in 1983 because we were producing UPSs for oil and gas. So we have knowledge about batteries or energy storage since 1983. In 1995, I guess that's someone from DOF in this room, we have done the first AC diesel propulsion system for DOF. So there we have been the first one doing something like this. We have been also the first one doing the DC propulsion system. It's called Blue Drive Plus C with the Edda Ferd. That was the name of the vessel for Östersjö. And this is a total DC concept with the variable speed drive generators that allows also to shut down all the generators that are not used because the load is in a way lower than what is the power demand. We have been again pioneers during the first electric ferry, 100% electric ferry called Ampere in Norway in 2015. And after that, it's not pioneering, but we opened our fully robotized battery factory in Norway. This battery factory is done for batteries that are completely water-cooled, 100% water-cooled. And the only thing that we buy outside are the battery cells that are coming from China and South Korea. All the rest of the packaging of the battery modules, as well the battery racks, and all the grids that we deliver are made by Siemens Energy, so we don't buy anything out of that. We have been also pioneers in other waves and shapes with regard to shipbuilding. We have been the first one doing a 100% fishing boat electric, Carolina, the first workboat electric, Elfrida. We have been the first one doing the Ampere, been again with the Blue Drive Plus C with Edda Ferd. We started the journey in 2012 for the Scanlines, hybridizing the ferries for Scanlines. We have done also the first hybridizing the offshore drilling rig with the power notation. And we have done also wellboats, the Row Vision with the DC propulsion and batteries. Then, the question is, everyone was saying, why did you open your own battery factory? There were also others, and we were buying before from third parties. The answer was very easy. Safety conditions were not according to what we mean safety should be. I can give you an example of an air-cooled battery energy storage thermal runaway. The thermal runaway is the worst event that can happen with batteries. So it's when the batteries are taking fire, basically. You see, this is air cooled. This is the burning of a single cell. So you see a single cell, what means, and how much energy it releases. And you see that it's not self-extinguishing. It's not to scare someone here, but it's because we have to be aware of what are the risks, and therefore we know how to manage the risks. We did a similar test with our batteries. Overcharging one cell in one module, stopping the water circulating because these are totally water cooled, and also stopping the extraction fan for the gases. So as you can see here, there was no fire, no propagation to other cells, and there were gases that were conveyed into that exhaust pipe that normally we do have in our system and conveys the gases out. A bit about the Blue Vault, that is the name that we have for our batteries. It's built like a switchboard, as you can see. There are also the protection doors in the front, because if something happens, then you know it's still also the operator protected. There are no cable connections in the front, as you can see. There are modules that are slide in, slide out. Configurations can find of 10, 9, 6, and 4 modules based on, let's say, the voltage level that we want to achieve. Totally water cooled, as I said. You see in the bottom on the left picture, there is the water inlet and outlet. And on the top, you see the plus and minus for the connection. And you see also the hole, as well also on the yellow part on the right figure, where there is the exhaust pipe, where it conveys the gases all out. You can see also here how it is, the single module. You can see from the single module that we do have also some on the module on the center down. You see that on the right side there are the water connection in and out. On the left side there are the pin plus and minus, and you see in the middle there are these 2 windows that are for, in case of thermal runaway, then gases are coming out and are conveyed there and going into fresh air. This is one module that is expanded. You can see very well that the yellow ones are the battery cells. The water flows in between all the cells, so in a way the cells are naturally separated by water. So meaning that also if a thermal runaway happens, the water, will take care of that, so will extinguish the fire. The water makes also it possible that you can have a let's say equal degradation of batteries, both from the first to the last one and from left to right. So you have a constant degradation of all the batteries. So this means that also the lifetime will be at maximum. You see also all these cards here. All these cards here are sensors that we do have for monitoring, and for monitoring temperature, humidity, state of charge, state of health, and these are based on a single cell level. Because as I said, for us, safety is the most important thing. You see again the backside of the switchboard of the battery system, where all the exhaust gases can be collected if something happens, and these are led into fresh air. So meaning that you can stay in the battery room eating, having dinner inside. There will be no problem also if a thermal runaway happens. Yes, and you can see also the battery management system that we do have from a cell level, where it is controlled temperature, voltage, voltage balancing, humidity, and all the alarms. These are wirelessly connected in between to a BIP that is on the top and can instantaneously disconnect the entire battery rack. And then from there, it's hardwired, connected all these battery racks that constitute, let's say, the battery system that we deploy. Most important is that, as I used to say, maybe someone heard from me today, batteries are stupid because batteries basically, they are on or they are off. What makes a battery intelligent are the frequency converters. So if you don't have very good grids and very good frequency converters, you can have the best batteries in the world. This will not, let's say, help us. We do have, in the same factory where we do manufacture the batteries, we do have also the frequency converters. We have both AC/DC bidirectional chopper and grid forming converters, as well as DC/DC. And you can see what is the specialty of those. You can overload them up to 200% for 5 minutes. So, it's quite huge, the overcharging that you can get with those. When we do DC grids, we do have DC-DC converters, and we do have also the switches. We have a switch called ILC that makes it possible to have a closed bus operation, also in DP3 closed bus, because that switch operates or can disconnect and segregate a failure in the ballpark of 7 microseconds, while a normal, just for your understanding, a normal mechanical switch can operate in around 100 milliseconds. So there are two different worlds in between. Lessons learned. The first lessons learned is that when we are having for the greenfield, the Blue Drive Plus C technology with the batteries, this provides higher availability, reliability, and profitability of the assets. Because as I said, with the variable speed generators, so lowering the number of generators online according to the load, this gives already to the ship the possibility of lowering the fuel consumption. When we have the batteries on the top of those, we can lower even more those because the batteries will stay there for spinning reserve and eventually peak shaving when needed. In the retrofit, because we are doing also retrofits, we have done the retrofits while the vessels were still in operation. So you don't have to take vessels out of operation or during planned maintenance. So this was important. I remember the colleague from Gusto mentioning that this might be a potential, let's say, problem. Another experience is, as we saw also before, the thermal runaway. So safety should not be compromised. And it's not a matter of money. A lot of time we talk about how much it costs the batteries, this battery compared to the other and whatever. I used to say, what happens if something happens and how much it takes to repair something. There are 3 cases here. What happened on 2 ferries in Norway and what happened also to our system. The first was a so-called water-to-air cooled battery, so it was not 100% water cooled. What happened on this vessel is that the vessel, we will see after, the batteries were not used too much, and they went in a kind of snooze mode. And then all the system, the alarm system, was in a way also sleeping, so not online. There was a thermal runaway generated. The vessel, there was a fire. This is how the vessel looked like with the thermal camera. So it's not something that we can when we talk about price, this we have to take into account if this happens. And here you can read, what happened there. Same happened for another smaller ferry with the air-cooled batteries. And you can see also the result of the thermal runaway that was generated from that. We have had also an incident with our batteries, with the Blue Vault. There was intrusion from this exhaust pipe in the main duct, the one in red that you do see, came water into because there were high waves and therefore came salt water inside. And with having this salt water, this went into the batteries, and of course the batteries were affected by that. The good part was that lessons learned after the owner went into that was detected that the problem was coming from a wrong design from the yard in doing the exhaust pipe. So that is the good part, at least from our side. But the good part was also to look into our batteries. So there was a nut fault on 3 modules, arc flash generated, no thermal runaway, no fire, no explosion. The vessel was continuing the operation. We changed the modules affected while the vessel was still more or less in operation without the batteries. And this was, in a way, showing again that maybe you can pay something more. This we know, Siemens Energy has never been cheap or the cheapest in the market, and I think that it's not our goal, but we want to be the safest in the market. About the future, quick. We are working, I think there are quite some that are working also with fuel cells. We have also the first contract signed with San Lorenzo. It's a luxury yacht, making luxury yachts in Italy. We have also deployed, just for your information, for Edda Wind, a lot of vessels that are hydrogen ready, and there is also there an EU research program for using a blended fuel, the LOHC, so that you can carry the hydrogen without any problem and you can burn it. What we do have also is that it's not for this, let's say, for you people, for the most of you, but for some, yes. We are working also with carriers, so LNG, shuttle tankers, and so on. We have also developed a solution called Ocean Green. So if you see, normally they are using 2 to 4 stroke engines. We are proposing a design where we do use our gas turbines, the SGT 400, marinized SGT 400, which include also batteries and DC grids. With this, they can achieve, as you can see, 18% reduction. And we have talked that 90% of vessels are bigger vessels for longer duration. So we have there 17% lower cost per unit, 90% reduction in SOx emissions, and also 7 to 10% increased capacity of a smaller footprint. So it means that you can transport 7 to 10% more goods if you want. The last one is also what Øystein was a bit in. We have been also looking to having the vessels to be charged at sea, in particular with can be done also with bottom fixed, but also with the floating. What is basically is that on that regard, we have been developing solutions that are called, one is called Blue Wind for the off-grid market, that we have been offering and doing a lot of studies where batteries are already included for other purposes and can be used also for charging the vessels. And we do have also a solution that before we called Blue Wind for grid plus storage for wind farms. People were asking me, okay, wind farm and you need batteries. Why do you need batteries for wind farm? My answer is very simple. Is with the introduction of renewable power and the fact that rotating masses are less and less on the land, you will have a lot of imbalances on the grid. And therefore, for fast frequency response and voltage control, for grid congestion, or if you want to do arbitrage, you will need different type of batteries. And one of the best places to put them is also out in the sea, because then you use less space on the land. And part of those can be used for charging the vessels, or the CTVs for doing those also full electric to have a back and forth. So this was a flavor, and for the last one, for the substations, I can't tell so much more, because I've started the patenting process, so finding the patent. So as soon as we do that, then we will present in a kind of wind conference for those. Thank you so much for your attention.